Hello everyone, welcome to the Internship Studios session on AWS Security Services, Cloud Governance and Migration Capabilities inside AWS. So it's very important for cloud and DevOps engineers to understand the security aspect of the cloud as well, because it's very easy to spin up resources in the cloud, but how you manage them with utmost security and prevent them from external world attacks or any cyber attacks becomes very important here. Also, migration also is very important since like we already know, like according to the recent advancements in the technology industry, migration and multi-cloud adoption is the way to go, because there is always something that is advantageous from one cloud to another. So a service comes up and the pricing may be the issue, the performance may be the issue. So it's always better that you all have your plans ready to migrate from one cloud to another. So we'll be seeing the different security aspects and migration and governance aspects in AWS in this session. So first, coming to the introduction to AWS Cloud Security Services, Cloud Governance and Migration. So AWS offers a wide range of cloud security services to ensure the protection of your data and resources. Cloud governance is essential for maintaining control and compliance in your cloud environment. Also, migration to the cloud requires thoughtful planning and execution to ensure a very smooth transition. So, cloud security is very critical aspect, as I already said, of managing data and applications in the cloud. So, it ensures confidentiality, integrity, and availability as well. So, AWS provides a very robust set of security features and services to help customers protect their assets in the cloud. So one key component of AWS security we have seen is the IAM, which is the Identity and Access Management System. So IAM allows users to manage access to AWS resources securely. For example, an organization can create IAM roles with specific permissions for different teams or individuals. So this ensures that only authorized personnel can access sensitive data or perform certain actions. So another important aspect is data encryption. So AWS offers services like AWS Key Management Service to manage cryptographic keys securely. For instance, when storing data in Amazon S3, users can enable server-side encryption to protect their stored objects. So this ensures that even if unauthorized access occurs, the data remains encrypted and inaccessible without proper keys. AWS also provides tools for network security as well, such as VPC. VPC allows users to create isolated network environments. So we also can control inbound and outbound traffic and establish the VPN connections. For example, a company may deploy its applications within a VPC, ensuring that the communication between different components is secure and isolated from the public internet. Furthermore, AWS also offers various monitoring and logging services such as AWS CloudTrail and AWS Config. So these services enable users to track changes to resources, monitor the user activity, and maintain the compliance. So an organization might use CloudTrail to audit API calls made on their AWS account, ensuring that any suspicious activities are detected and investigated promptly. So coming to cloud governance, governance usually involves establishing and enforcing policies and procedures to ensure effective and compliant cloud usage. So AWS provides several services to assist organizations in implementing governance frameworks tailored to their specific needs. So AWS organizations is a very key service for managing multiple AWS accounts within an organization. So this allows for centralized control over billing, access control, and compliance. So for instance, an enterprise with different departments can use AWS organizations to consolidate billing information and manage access to resources across the various accounts. Also, we have something called as AWS config rules. So it enables users to define and enforce policies for their AWS resources. For example, an organization might create a config rule to ensure that all Amazon Elastic Compute Cloud EC2 instances are launched with specific security configurations. So if any resource violates this rule, AWS config generates an alert allowing administrators to take corrective actions. Also, cost management is a critical aspect of cloud governance. So AWS provides tools like AWS budgets to set cost and usage thresholds. So organizations can define budget alerts to receive notifications when spending exceeds predefined limits. So what this does is this ensures that financial goals are met and resources are used efficiently. Moreover, AWS service control policies allow organizations to set fine-grained permissions for their accounts. So SCPs help enforce security and compliance requirements by controlling access to AWS services. For instance, an organization may use SCPs to restrict certain departments from using specific AWS services that are not compliant with internal policies. So next is a cloud migration in AWS. So cloud migration involves moving applications, data, and other elements of an organization's IT infrastructure to the cloud. So it may be from on-premise or it may be from cross-cloud. For example, Microsoft Azure to Google Cloud or Microsoft Azure to AWS, AWS to Azure, vice versa. So here what AWS does is it provides a very comprehensive set of services and tools to facilitate smooth and efficient migration processes. So we have something called as AWS Server Migration Service. So it allows organizations to migrate on-premises virtualized servers to AWS. So this service amplifies the migration process by automating the incremental replication of live server volumes. For example, a company with existing virtualized servers in their on-premises data center can use SMS to migrate those servers to AWS without significant downtime. So companies nowadays also do data migration, which is another critical aspect of cloud migration. So AWS offers the database migration service to facilitate the migration of databases to and from AWS. So an organization may use DMS to migrate an on-premises Oracle database to Amazon RDS for PostgreSQL, ensuring minimal disruption to business operations. So for whole application migrations, AWS provides services like AWS Migration Hub and AWS Serverless Application Model. So Migration Hub provides a central location to plan, track, and execute application migrations. So SAM, which is Serverless Application Model, allows developers to define serverless applications using cloud formation templates, which is an automation tool. So simplifying the development of serverless architectures on AWS. So additionally, AWS provides a range of tools for data migration such as AWS Snowball and AWS Data Sync. So AWS Snowball is a physical appliance that allows organizations to transfer large amounts of data to and from the cloud very securely. So Data Sync enables online data transfer between on-premises storage and AWS storage services, ensuring efficient and reliable data migration. So in conclusion, like AWS offers a robust set of security, governance and migration tools and services that organizations can leverage to build secure, well-governed and seamlessly migrated cloud environments. So this was about a bit of an introduction. So initially we have the IAM, which is the first thing in securing our cloud. So IAM enables you to manage user access and permissions for AWS services and resources. So with IAM, you can create and manage users, groups, and roles with fine-grained access control. So IAM also supports multi-factor authentication and integration with external identity providers. So you can actually leverage IAM for if you have a big enterprise environment, then you can segregate teams for developers or testers and DevOps engineers. Automatically, you can create the user groups in IAM and add the respective people in that groups for fine-grained control. So we have that capability to manage the users, groups, and roles. So role can also be assigned to them, to which they can do the cloud operations accordingly. So as we already saw, like it also enables MFA. So MFA is like multi-factor authentication. So since credentials are very important when logging in and out of the cloud, so it MFA is plays a very like a cop role, you can say. So it's like a additional security layer on top of the existing authentication. So there may be chances someone can hack into your credentials and just pin up some resources in the cloud, and that will also it will affect the business of the enterprise as well. So there, if you have MFA enabled, then you can configure your device or a hardware device for MFA, and it will be safe. Like there will be no mishaps afterwards. So this was about the IAM. Next, we also have the CloudTrail. So CloudTrail provides detailed logs of all API calls made in your account. It helps with troubleshooting, monitoring, and compliance auditing. Next, CloudTrail logs can be stored in Amazon S3 or sent to other AWS security services such as Amazon CloudWatch or AWS Config. So trail means it's like providing a detailed record. It's in the name itself. So it actually provides a detailed record of actions taken by the users you have created, the roles you have created, or service within your AWS account. So it's like it captures the information about who made the request, what actions were performed, when the actions occurred, and the according resources involved. So it, in simple terms, you can say CloudTrail acts as a log or audit trail for your AWS environment. So first what it does is, so CloudTrail records events or activities that occur in your AWS account. So these activities can include anything from creating an EC2 instance to changing the security group settings. So, but you need to set up a trail actually. You can set up a trail in CloudTrail to define where and how the logs should be stored. So the trail specifies the AWS S3 bucket where the logs will be saved and can include additional configurations as well. So this S3 bucket, what it acts is, it acts as a very secure and durable storage location for the logs. Also it allows for monitor and audit the history of your AWS account activity as well. So you can use the logs for security analysis, resource change tracking, compliance, and troubleshooting. Also, logs are very important. So they include information such as the identity of the user or service making requests. So the actions they perform and the resources affected. So the relevant timestamps are recorded, providing a chronological view of events. It's like event A happened at this time, event B followed up after event A. So you'll get a proper recorded timestamps. Also, this has a good integration with other AWS services as well. So CloudTrail can integrate it with other AWS services such as AWS CloudWatch, which are already seen as a monitoring tool, and CloudWatch logs for additional analysis and alerts. So also you can customize CloudTrail settings based on your needs, such as filtering the events you want to capture or configuring multi-region trails. So it's like end of the day, it's like a watchful guardian for the AWS environment, keeping a detailed log of every action and change. So next we have the AWS config. So AWS config tracks changes to your AWS resources over time. Also it provides a detailed inventory and configuration history of your AWS resources. AWS config enables you to assess the compliance and security of your infrastructure. So as the initial process, AWS config, it keeps track of configurations for AWS resources. So such as EC2, S3 buckets, IAM roles, and more. So it also provides a historical record of changes, allowing you to see how configurations evolve over time. So again, AWS config maintains a timeline or history of configuration changes, making it very easy to understand when changes occurred and who made them. The history actually it aids in troubleshooting, auditing, and understanding the impact of modifications to your resources. Also, it has a facility for continuous monitoring as well. So it continuously monitors your AWS resources, automatically detecting changes and updating the configuration history. So this real-time monitoring helps you stay informed about the state of your resources and respond promptly to any unexpected changes. So you can also create the configuration snapshots at specific points in time to capture the state of your resources as well. So these snapshots, what they do, they serve as a reference points for compliance checks or auditing purposes. Also, this allows you to define some rules to check whether your AWS resources comply with your organizational policies and industry standards. For example, you can create a rule to ensure that all S3 buckets should have logging enabled for compliance with security best practices. So another important thing is in some cases what happens, AWS config can automatically remediate non-compliant resources based on predefined rules. For instance, if a resource is found to be in violation of a rule, AWS config can trigger an automated action to bring it back to compliance. So it also has a very good integration with other AWS services. So AWS config integrates with other AWS services such as AWS CloudWatch, allowing you to visualize and analyze configuration data through dashboards and metrics. So in essence, this is also a very powerful tool for maintaining visibility and control over AWS resources. So it helps you ensure that your configurations align with best practices, regulatory requirements, and internal policies, promoting a very secure and compliant environment. So next is the AWS CloudWatch. So CloudWatch monitors the AWS resources and applications in real time. So it collects and displays metrics, logs, and events from various AWS services. So CloudWatch alarms can be set up to trigger notifications or automated actions based on predefined thresholds. So primarily it helps in monitoring. So for a wide range of AWS resources, including EC2, S3, RDS, Lambda functions, and much more. So it collects, stores data, providing a unified view of your resources performance as well. So there's the concept of metrics and alarms here. So CloudWatch collects data in the form of metrics, which are numerical values representing the performance of your resources. So also you can set up alarms based on these metrics to receive notifications when certain conditions are met, helping you are proactively address issues. So dashboard creation also is there. So CloudWatch lets us create a custom dashboard to visualize and organize metrics for multiple resources. So dashboards provide a very consolidated view of your application or infrastructure performance. So CloudWatch logs also allows us to capture and store log data from the applications, making it easy to search, analyze, and troubleshoot. So this is useful for understanding the behavior of the applications and diagnosing the issues as well. Also there is a concept called events. So CloudWatch events enables us to respond to changes in the AWS environment by triggering automated actions. For example, you can automate the scaling of EC2 instances based on certain conditions detected by CloudWatch. So in addition to AWS resource metrics, you can also publish the custom metrics and logs to CloudWatch. So this flexibility allows you to monitor and analyze the specific aspects of your applications or workloads. So in summary, AWS CloudWatch is the go-to tool for monitoring, managing, and gaining insights into the performance and health of your AWS resources. So either you need to set up alarms for critical thresholds, analyze logs, or automate responses to events. CloudWatch enables the tools to keep your AWS environment running very smoothly. So next we have the AWS Shield. So AWS Shield protects against distributed denial of service, which is simply called as DDoS attacks. So it provides both standard and advanced DDoS protection for web applications and APIs. So AWS Shield integrates with AWS WAF, which is the web application firewall, to provide comprehensive security. Shield means it's like a protective armor, we can say. So in the historical days, we had an army of soldiers who had wielded the shields in their hands. So it will protect from any external attacks. So similarly, AWS has named this feature as AWS Shield. So it has been designed to defend against DDoS attacks, which are attempts to overwhelm an online service by flooding it with traffic. So hackers, what they do, they will intentionally create some bots and try to access the page. So when there are thousands and millions of requests and that application will not be able to handle that request, then what it will go, it will be offline. So the server becomes down due to huge influx of requests. So DDoS attacks can also disrupt services of applications. So it will lead to downtime and then negatively impact the user experience. So the shield also continuously monitors the network traffic and automatically detects patterns indicative of a DDoS attack. So when an attack is identified, AWS Shield initiates mitigation measures to minimize its impact. So AWS Shield also provides DDoS protection at a global scale, so covering all the AWS customers across the world. So it leverages the vast AWS network infrastructure to absorb and mitigate large scale attacks. So there are some couple of plans with it. One is the standard plan it comes with and the advanced plan. So Shield, there's something called as Shield standard. So this is automatically included at no extra cost with all AWS customers. So it provides the basic DDoS protection for all AWS customers. But if you want the Shield advanced plan, this is a subscription based plan that offers enhanced DDoS protection and additional features for customers with more complex security needs. So WAF integration is awesome with AWS Shield, which is a web application firewall service. So this integration allows for comprehensive defense against both DDoS attacks and application layer attacks, providing a very holistic security approach. So Shield Advanced includes something called as a Global Threat Environment Dashboard. So the GT dashboard provides insights into the global DDoS threat landscape, helping organizations stay informed about emerging threats. So there's another thing called the 24 by 7 DDoS response team. So the AWS calls it as DRT. So customers who are having AWS Shield Advanced have access to the AWS DDoS response team, a team of security experts available around the clock from AWS. So the DRT team can provide the guidance, assistance, and real-time support during DDoS attacks. So it is a very cost-effective offering as well. So by leveraging AWS Shield, organizations can benefit from cost-effective DDoS protection without the need for significant investments in specialized hardware or infrastructure. So in summary, you can say AWS Shield is a very crucial service for safeguarding your AWS applications and websites against DDoS attacks. So whether you are using the included Shield standard plan or opting for the advanced features of Shield Advanced, AWS Shield helps ensure the availability and resilience of your online services in the face of evolving cyber threats. Next, we have the Amazon WAF, which is also short for Web Application Firewall. So AWS WAF protects your web applications from common web exploits and attacks. So it allows you to create rules to filter and block malicious traffic. AWS WAF integrates with AWS CloudFront and application load balancers for easy deployment. So there would be some common web exploits and attacks such as SQL injection, cross-site scripting, which is common as XSS, and cross-site request forgery, which is called as CSRF. So What these exploits can do is they can lead to data breaches, unauthorized access, and manipulation of sensitive information. So next is the rule-based security policies. So with AWS WAF, you can create and configure security rules that define how incoming web traffic should be handled. So rules can be customized to block or allow requests based on various criteria. So including IP addresses, HTTP headers, and request patterns. So it also provides some managed rule sets that offer pre-configured rules designed to protect against common threats. So these rule sets cover a broad range of security issues and are regularly updated to address emerging threats. So it integrates seamlessly with CDN and application load balancers. So it allows us to deploy WAF protections at the edge locations closer to the users. So for improved performance and lower latency. So it also enables to set up something called as rate limiting to control the number of requests from a particular IP address. So it also helps protect against automated bots and scrapers, allowing us to differentiate between legitimate and malicious traffic. So you have the flexibility to create some custom rules and conditions tailored to the application's specific needs. So this allows us to address unique security requirements and enforce business specific security policies. Also, it provides detailed logging of web requests and actions taken by the firewall. So you can use AWS CloudWatch to monitor and analyze these logs, gaining insights into potential security threats and patterns. Also, it has a real-time threat intelligence capability. So it leverages threat intelligence feeds to stay updated on the latest security threats. So this helps ensures that your web applications are protected against evolving and emerging security risks. So AWS WAF is, in a nutshell, it's a crucial component of a comprehensive security strategy if you have for web applications. So it provides the means to define and enforce security policies, block malicious traffic, and protect against a variety of web-based attacks, contributing to the overall resilience and security of your web applications hosted on AWS. So this is about the WAF. Next we have the guard duty. So guard duty is a managed threat detection service that continuously monitors for malicious activity in your AWS accounts. So it analyzes AWS CloudTrail logs, VPC flow logs, and DNS logs to identify potential threats. Guard duty uses machine learning algorithms to provide intelligent and actionable alerts. So guard duty helps us in mitigating various types of threats and suspicious activities in our AWS environment. So it continuously analyzes log data, CloudTrail events, and VPC flow logs to identify any potential threats. So it also integrates with various AWS services as well, including CloudTrail, VPC flow logs, and DNS logs. So guard duty detects common types of threats such as unusual API calls, potentially compromised EC2 instances, and malicious IP addresses. So it helps identify activities associated with cryptocurrency mining, brute force attacks, and other malicious behavior. So it incorporates threat intelligence feeds from various resources, including AWS partners and the broader security community. So this ensures that the service is up to date with the latest information about known malicious entities and attack techniques. So when guard duty identifies a potential security threat, it generates security findings. So these findings provide detailed information about the detected activity, allowing you to investigate and respond to security incidents. So again, guard duty prioritizes alerts based on the severity and potential impact of the identified threats. So this helps focus on the most critical security findings that require immediate attention. So guard duty also provides a centralized security dashboard where you can view and manage security findings. So the dashboard includes visualizations and details about ongoing security threats and their status. Also, it doesn't require the deployment of additional infrastructure, making it a convenient choice for enhancing your AWS security posture. So, in summary, AWS Guard Duty is a valuable service for continuously monitoring and detecting potential security threats in the AWS environment. So, next we have the AWS Secrets Manager. So, Secrets Manager helps you securely store and manage sensitive information such as database credentials and API keys. So it provides automatic rotation of secrets to enhance security. So Secrets Manager integrates seamlessly with other AWS services like Amazon RDS and Amazon Redshift. So instead of scattering sensitive data across your applications, Secrets Manager allows you to centralize the secrets management in one place. So for example, it can update your database password regularly to enhance security. So it automatically rotates or changes the stored secrets on a scheduled basis. So for example, applications running on EC2 instances or Lambda functions, for example, can easily retrieve and use secrets without hard coding them. So you can also control who has access to different secrets using AWS identity and access management system. So this ensures that only authorized users or services can retrieve sensitive information. So Secrets Manager also keeps track of the different versions of your secrets. So this is helpful for auditing purposes and allows you to revert to a previous version if needed. So all stored secrets in the Secret Manager are encrypted using industry standard encryption techniques. So this ensures that even if someone gains unauthorized access to the stored data, they can't easily decipher it, means they can't uncover it. So also it has a easy integration with other applications. So applications can programmatically retrieve secrets from secret manager, making it easy to keep sensitive information secure without hard coding it in your code. Also it provides for logs and audit trails, so you can see who accessed which secret and when. So this helps in monitoring and maintaining a record of secret usage. So in essence, AWS Secrets Manager simplifies the secure storage and management of sensitive information in your AWS environment. So it's like having a highly secure, organized vault for your secrets with added features like automatic rotation and seamless integration with your applications. So this ensures that your sensitive data is kept safe and easily accessible only by authorized users and services. So next we have the AWS Artifact. So Artifact provides on-demand access to AWS compliance reports and documentation. So it simplifies the process of meeting regulatory and audit requirements. Artifact offers a repository of downloadable AWS security and compliance documents. Actually, it provides a wide collection of compliance documentation. So these documents they help customers understand the security controls and practices implemented by AWS to protect their data and resources. So the documentation available in AWS Artifact it covers a wide range of security and assurance programs, such as we have the SOC, which is the Service Organization Control Reports, ISO certifications, which is the International Organization for Standardization, and PCI DSS, which is the Payment Card Industry Data Security Standard Reports. So customers can review these documents to ensure that AWS adheres to industry standard security practices. So users can access AWS Artifact on demand. So the flexibility is useful for regulatory audits, compliance checks, or contractual requirements. So there are some types of documents as well. So it includes various types. For example, it includes compliance reports. It may include third-party assessments and agreements. For example, customer can find the AWS compliance reports that detail how AWS infrastructure and services meet specific regulatory standards. So customers can access agreements and contracts related to their use of AWS services. So this includes the AWS customer agreement and the AWS business associate addendum among others. So AWS helps it easy so that users can easily download and review the documents relevant to their compliance and security needs. So this helps customers verify AWS's commitment to security and understand the shared responsibility model. So AWS audit like this artifact supports customers in their audit and assurance activities by providing transparent and verifiable information about AWS's security practices. So this is particularly important for businesses subject to regulatory requirements or those with specific security and compliance standards. So it's accessible through the AWS Management Console as well, making it convenient for customers to navigate and retrieve the necessary documents. So in a summary, so AWS Artifact is a very valuable source for AWS customers who need to verify and understand the security and compliance practices of AWS services. So it provides an on-demand access to a variety of documentation, allowing users to meet the regulatory, audit, and contractual requirements effectively. So there's a point called cloud governance best practices. So it means when you are operating in the cloud, we need to define clear roles and responsibilities for managing cloud resources. Also, we need to implement a tagging strategy to categorize and organize resources. We also regularly review and audit the cloud environment for compliance and security. So why it's required is initially cost management option is also there. So cloud services often operate on a pay as you go model as we already know, and costs can quickly escalate without proper oversight. So as part of best practices, we need to establish the cost controls and budgets. We need to implement the resource tagging for cost allocation. So we should regularly review and optimize the resource usage as well. Also, there's some security and compliance issues involved. So security is a shared responsibility between the cloud provider and the customer. So compliance with industry standards and regulations is very essential here. So we should define and enforce security policies. We need to regularly audit and assess security postures. We need to use identity and access management controls. We also need to implement encryption for data in transit and at rest. So also efficient use of resources is also critical to avoid underutilization or over provisioning. So we should implement the automated provisioning and deprovisioning. So we also need to monitor resource utilization and scale dynamically. We need to leverage IAC for consistent deployments. Also, controlling access to resources and ensuring proper authentication are fundamental for security as well. We need to implement the principle of least privilege. We need to regularly review and audit IAM roles and permissions. We also need to use IAM for multi-factor authentication for enhanced security. So coming to the cloud migration strategies, there are some migration strategies which are in place in the modern times. We have the lift and shift, where we can move applications and data to the cloud without significant modifications. We have concept of re-platforming, so we can optimize applications for the cloud by making use of cloud native services. Then we have the option of re-architecting, so we can redesign applications to take full advantage of cloud capabilities and scalability. So lift and shift is also called as rehosting. So rehosting involves lifting the existing application and shifting it to the cloud without making significant changes to its architecture. So this strategy is suitable for legacy applications, means old applications that can run in the cloud with very minimal modifications. So there are some benefits which is like the initially is quick migration. We can do a very quick migration with this, and then there are some very minimal code changes required, and there are immediate cost savings which can be seen. Next is the replatforming, which we can also say as lift tinker, and shift. So replatforming, it involves just making some adjustments to the application during migration to take advantage of certain cloud features. So use case may involve organizations may use this strategy to optimize their applications for the cloud environment while avoiding major code changes. So benefits include improved performance, scalability, and cost efficiency compared to a simple lift and shift. So coming to re-architecting, which in the cloud environments and some cloud architects refer to as refactoring as well. So refactoring involves making changes, significant changes actually to the application architecture to optimize it for the cloud environment. To optimize it for the cloud environment. So use cases, it's suitable for applications that require modernization, scalability, and the use of cloud native features. Next we have some cloud migration tools as well. So first is the AWS server migration service. So it simplifies the process of migrating on-premise virtual machines to AWS. Next we have the AWS database migration service, which facilitates the migration of databases to AWS. So next we have the AWS Snowball, which provides a secure and efficient way to transfer large amounts of data to and from AWS. So there are some cloud migration challenges. So legacy applications may require significant modifications for cloud compatibility. So because they are using a very obsolete technologies which are around 10 or 15 years old, so it can be challenging to make them match to the current tech requirements. So again, data migration can be complex, especially when dealing with large volumes of data. So ensuring minimal downtime during the migration process is a crucial challenge. So if the application is already live in the production and you are just migrating with that in place, so you also want the application to be live and also you need to migrate, then the downtime that is required while you are moving that data, so ensuring that and it is very minimum, that is a very big challenge. So that's why we need to carry forward with best practices consulted by some good cloud architects so that they will help us in migrations. Next is the cloud migration planning. We need to assess the current infrastructure and identify workloads suitable for the migration. So we should develop a migration plan that includes a timeline, resource allocation, and testing strategy. And also we need to consider the impact of migration on security compliance and performance. So there must be some planning phase involved beforehand, and we need to foresee and able to have a foresight of what things can go wrong and how much customer uh, issues of bandwidth we can actually take upon ourselves. So this is a very important part so that we can in beforehand be prepared for the migrations. Next, there are some cloud migration risks involved as well. So data loss or corruption during the migration process can happen. So there will be some incompatibility issues with existing applications and there may be some dependencies. So lack of proper testing and validation before going live in the cloud is also very big risk. So for example, if you are moving from data transfer methodologies, so some data may get corrupted. For example, if you are moving from Google Cloud to AWS using the storage transfer service of Google Cloud, so there may be chances that some files may not reflect as it is in AWS. Also, there might be some compatibility issues. For example, some Postgres servers versions may not be exist in the cloud, but you are using that version in your own data centers. So that may become a major issue. Then we need to properly test for all the fail cases before moving to the cloud migrations. Next is the cloud migration testing. So we need to conduct thorough testing of migrated applications and infrastructure in a non-production environment. So we need to validate performance, security, and compatibility with the existing systems. We also need to implement a rollback plan in case of unexpected issues or failures. So in case in the middle of the migration there are some very critical issues, like it's not happening as per the plan. So you should have a system built in already so that you can just stop the migration in midway and just roll back to the existing environment that you had previously. So this will help in very minimal disruption to the customer facing applications and also help in reducing the revenue loss for the enterprises. So there are some cloud migration, post migration tasks. So we need to optimize and fine tune the cloud resources for better performance and cost efficiency. Also, we need to establish monitoring and alerting mechanisms to proactively detect and resolve issues. Also, we need to train the team on managing and operating in the cloud environment. So, since people who are already exposed to the on-premise operations, they are mostly familiar. The existing technology is same, but just they have modernized some resources. But you have to train the team accordingly to handle the after migration activities. They need to understand how the cloud works, how different services offer what kind of features, and also they need to be playing around with the different services so that they will help in keeping track of health of the application. So next is the cloud governance framework. We need to define cloud policies and standards aligned with the organization's goals and compliance requirements. We need to establish mechanisms for continuous monitoring and assessment of the cloud environment. So we need to implement automated controls and workflows to enforce governance policies. So you need to set some predefined rules. For example, there are some GitHub related administration. What you can say, you can devise a framework across the organization so that there is some approvals required from the managers or the cyber security teams if you want to access a certain kind of websites so that our existing source code repositories are very safe and are not open to the public. So there are some also mechanisms. We should also have a habit of continuously having a monitoring setup. So we can use available tools like native cloud monitoring solutions or the Prometheus and Grafana dashboards so that we know what is happening in our cloud and we can assess the workflows accordingly. So this is a kind of pictures where there are some on-premises Oracle database. Source can be like it on-premises, Amazon EC2 or RDS. So we have the Amazon database migration service, which can have the target where we can migrate it to the Amazon RDS for Oracle database. So next, it may be some MySQL database also in the on-premise or in Amazon EC2 or Amazon RDS, which can be a source. And using the database migration service available in AWS, we can move to the Amazon Aurora database. So this is just pictorial view of how the migration takes place. So next we have the portfolio assessment. We have like first the migration evaluator, which helps us uh, beforehand to plan the migration. Then we have the AWS application discovery service, which helps us to map the services from on-premises and their existing counterparts in the AWS. Next we have the AWS migration hub, which is like a one point shop for all the migration related activities. So for lift and shift, we can lift this old legacy data center servers using the AWS application migration service, which is short for MGN, to the latest Amazon EC2 instances. To re-platform the databases, we can use the AWS database migration service tool, and then we can map it to the AWS relation database service. So to re-platform the containers who are hosted on .NET or old Java-based web applications, we can use the application to container service. Then we can then manage those containers using EKS, which is the Elastic Kubernetes Service, or ECS, or Fargate. ECS means the Elastic Container Service. So the top 10 AWS migrations that we currently have are these. So we have the migration evaluator, which will beforehand we can use to plan the migration accordingly. So what amount of downtime we can expect, what amount of cost we can save. So it will give a evaluator to forecast the migration process. Next, we have the cloud adoption readiness tool. Next, we have the migration hub. Next, we have the application discovery service. We have the landing zone. We have the application migration service, the server migration service to just only migrate the servers from like legacy servers to EC2. We have the database migration service. We have the VMware cloud. So if you have any VMware hosted solutions, those also you can host on AWS. Next, we have the AWS marketplace, which is kind of helps us in bringing the SaaS solutions, which is a software as a service. So this kind of a higher migration level. So it's like a cross cloud migration. So we have a corporate data center or an Azure environment. So we have the server migration connector, which helps us to connect to the AWS server migration service. So we have the Amazon VM export or import service here. Then accordingly we have the Amazon EMIs. So we can map those EMIs to the cloud formation template again, and then it can deploy the resources accordingly in our AWS target account. So this is the high level workflow of how this high level migration takes place. So next is the different types of rehosting that's available. So first is the legacy platform. So in the legacy hardware emulation, so we'll just modernize only the OS related and hardware systems, but the OS and all the middleware database files and the application code remain same. And in the legacy middleware emulation, the beneath cloud and the OS and the application layers and the related utilities are hosted on the cloud, but the application code and data format remains as per legacy. And the legacy automated refactoring involves all the application related things hosted on the cloud, but only the business functions change here, remain same. So modern middleware replatforming involves hosting the all the AWS related things in AWS cloud, like all the servers and the OS related things, but in this business functions, application code, utilities for data format, and application middleware and database and files. This will involve a mix of legacy and cloud related components here. So these are the some frameworks. One is the security, finance, central IT, networking, operations, and software engineering. So these are the different kind of strategies. One is the compliance reporting, one is the standard cloud strategy. We need to define the consumption policies as well here. So we have the AWS artifact, we have the AWS environment. We can select a home region close to the customers so that it will be easy for latency related issues. And in main home region, we can also host the main workloads. So here are some compliance requirements we need to fulfill, like the HIPAA, GDPR, NIST. So based on different countries, we have different compliances then we need to fulfill. So also there are some governance related ones, parameters like the policy for security, policy for availability, policy for cost optimization, which we may have a policy for observability and other customizable policies. So each department of cloud operation must have a specified policy, and we can make them in a single point of solution in the policy control library. So we had an overview of how these AWS cloud services, security services are, and how the governance and migration strategies are worked upon. So hope you understand the theoretical concepts. Uh, Thank you for attending the session. Bye everyone.